Good. So let us start today's lecture with this computer known as ABC computer, and it was developed in between 1939 to 1942. And this computer is developed as, let us see the different parts of computer. So this is left hand side one is the actual model, and right hand side shows the prototype. Okay, in that prototype you can see that carry over drum is there, motor is there to run this device, power supply and regulator is also there, 30 add subtract logic circuit. So because you are computer science student, so this will come in your digital electronics subject. Okay, this memory re generating circuit is also coming under digital electronics and computer system and architecture subject. Electric card punching circuit is also there. So this is traditional circuit. Now come to base to output card puncher, base to card reader, base to card reader, and base to output card puncher is binary logic. Okay, so this is also coming under digital electronics. Now come to decimal to binary conversion, the same thing. Then keyboard drum is there. So each and everything is here in terms of analogous system, analog system. Okay, nothing is digital, and you won't be able to see the answer in terms of digit. Only some display is shown here on the basis of will be able to predict the answer. So this is how this ABC computer is coming into existence, and this is named. Yes
sir. आपकी पूरी आवाज नहीं आई, कैसे डिस्प्ले होता है?
डिस्प्ले कैसे होता है ये सिस्टम?
हाँ जी.
Yes, so there will be one video. It will coming in next slide also. So there are switches and there are light panel. Okay, on the basis of this light panel, you will be able to see that what will be the answer, and printer is also there, printer and puncher. On the basis of this, you can print the output. Okay, so that time printer was the output device, printer and card reader. Okay, these are the output devices. So on the basis of these outputs, we can say that our system is working correctly. So this was electronic computer, first electronic computer built by John Atenosoft and Clifford Barry. So Barry, Clifford and Atenosoft. So due to this, we use the abbreviation of this, and acronym for this means the short form for this particular system is ABC computer, Atenosoft and Clifford Barry. Fine. Now come to next slide. So this is the first digital computer, and binary system is still in use today. So this will remain. How we will see in number system slide also. So this was ENIAC or ANIAC. Some persons pronounce it as ENIAC and some says ENIAC. Okay, so this is electronic numerical integrator and computer, ENIAC, ENIAC. And the specialty of this system, it was developed in 1946 and based on vacuum tubes, a machine that computes at a speed of 100 times faster than Mark 1. Mark 1 was 8 cross 56 dimension, 8 feet cross 56 feet dimension system. Okay, as earlier already seen, and was capable of only 2 years earlier. So before this, in 1943 or 44, the Mark 1 was developed. Using 18,000 to 19,000 vacuum tubes, 70,000 resistors and 5 million standard joints, this massive instrument required the output of a small power station to operate it. So one small power station is also required to operate it, because so many vacuum tubes are there, and vacuum tube it uses a very huge amount of power. It could be calculation in 2 hours, just 2 hours. And before this, it was 100 into 1 year. That is 100-year calculation. Okay, because 100 engineer requires a year to do by hand. Fine. So 365 days, not 365 days. It is 3,600 days of computation. And now with this system, it is in just 2 hours. The system's program could be changed by rewiring panels. So these are the panels, and this is hardwired logic. So you need to change the wires. It will automatically convert adder into subtractor, subtractor into integrator, and so on. And the weight of this system is 30 ton, and it was installed in 1500 square feet. Okay, so 1500 square feet average 3-bedroom house, and nowadays 800 square feet is sufficient for 3-bedroom house, but that time it requires 1500 square feet. You can see that how long this is. Okay, the dimension, you can see how this system is installed in a room of 1500 square feet. So let us see the demonstration before going to show you demonstration. What is computer? Computer is an electronic machine, accept data, process it according to instruction, and provide the result as new data. And it can make simple decisions and comparisons. Okay. And program is a list of instruction written in a special language like C, C++, ADA, etc. that the computer understands. Fine. So let us see. So voice is coming. Okay.
In February 1946, the U.S. government revealed to the public the existence of a secret computer, which had been developed under the code name Project PX. The computer was called ENIAC, a massive electronic digital computer. Begun in 1943, under the authority of the U.S. Army, the ENIAC was developed at the Moore School of Electrical Engineering at the University of Pennsylvania. The following film is perhaps one of the earliest existing video records of a fully operational electronic digital computer ever made. This originally silent film has been carefully edited to remove lighting imperfections and other issues present in the original. In all other respects, it contains 100% of the original film footage and is provided here for historical purposes. ENIAC stands for Electronic Numerical Integrator and Computer. It was the world's first large-scale digital electronic general-purpose computer. It was designed to be capable of being reprogrammed to solve a large number of numerical problems. ENIAC was conceived and designed by John Mauchly and J. Presper Eckert of the University of Pennsylvania. They headed up a team of engineers and others that worked on the ENIAC project, which began in 1943. The team that worked on the ENIAC included a large number of women who were instrumental in the detailed task of manually programming this giant machine. Programming was accomplished by setting switches and connecting wires according to specific instructions, which were first worked out on paper, carried out and tested. Mapping the program out on paper took weeks. The task of setting the switches and wiring cables to match the program diagram then took many days to complete. When it was originally designed, there was no written manual on how to program the ENIAC. The women involved in the actual programming of the machine relied on block diagrams and logic diagrams of the machine's operation, as well as personal talks with the engineers directly responsible for specific parts of the ENIAC machine. In 1997, the 6 women who did most of the programming of ENIAC were inducted into the Women in Technology International Hall of Fame. In addition to switch panels and wiring panels, ENIAC used an IBM punch card reader for input and an IBM card punch machine for data output. The timing of these machines was synchronized with the operation of the ENIAC itself. The ENIAC was a very large machine. It weighed over 30 tons. The ENIAC had a total of 40 panels and utilized 18,000 vacuum tubes, with 70,000 resistors and 10,000 capacitors. ENIAC also had its own dedicated power lines. To keep the vacuum tubes from overheating, the room was air-cooled. When ENIAC was announced in 1946, the news media called it a giant brain. Its computing speed was 1,000 times greater than that of electromechanical machines. This computational power, along with its general-purpose programmability, made it a technical marvel of its time. ENIAC's design and construction was financed by the United States Army. The construction contract was signed on June 5, 1943, and work on the computer began the following month. The cost of the ENIAC in 1946 was just under $500,000, which is equivalent to over $6 million today. ENIAC was formally accepted by the U.S. Army in July 1946. ENIAC was temporarily shut down on November 9, 1946, and a memory upgrade. It was then transferred to Aberdeen Proving Ground, Maryland, in 1947. There, on July 29, 1947, it was turned on and remained in continuous operation until it was powered down on October 2, 1955. ENIAC was initially designed to calculate artillery firing tables for the United States Army's Ballistic Research Laboratory. A typical ballistics calculation that previously might have taken 12 hours using a desktop mechanical calculator could now be done in just 30 seconds. The ENIAC's other applications included weather prediction, atomic energy calculations, cosmic ray studies, thermal ignition, random number studies, wind tunnel design, and other scientific uses. Here, output from one of ENIAC's printers is being produced. In this scene, we see brilliant ENIAC designers J. Presper Eckert on the left and John Mockley on the right. They would continue their involvement in computer design and manufacture far beyond ENIAC in the years to come. Even before ENIAC was fully operational, both Eckert and Mockley realized they could design and build a significantly more capable and efficient computer, incorporating some design improvements. They began working on a computer they called the EDVAC. EDVAC was delivered to the U.S. Army's Ballistics Research Laboratory in 1949 and made fully operational by 1951. In 1946, the University of Pennsylvania adopted a new patent policy, which would have required Eckert and Mockley to assign all their patents to the university if they stayed beyond March. Unable to reach agreement with the university, both Eckert and Mockley left the Moore School in March 1946, along with many of the senior engineering staff. Soon afterwards, Eckert and Mockley started up the Electronic Control Company. They later changed the name to the Eckert-Mockley Computer Corporation, or EMCC. By October 9, 1947, they had a contract with Northrop Aircraft to build the BINAC, or Binary Automatic Computer. EMCC was officially incorporated in December 1947 and was the first commercial computer company founded specifically to produce electronic digital computers. The EMCC had also been working on another computer, the UNIVAC. Before the UNIVAC was completed, Remington Rand purchased EMCC, which then became the UNIVAC division of Remington Rand. UNIVAC 1 was released in 1951. In 1955, Sperry merged with Remington Rand, and the name Sperry Univac was used on many computers until Sperry dropped the name Univac in 1984. Sperry merged with Burroughs in 1986, and that company became Unisys. Here, Herman Goldstein, one of the development team, reads ballistics data output. Today, a portion of the ENIAC still resides at the University of Pennsylvania. Other components of ENIAC reside at the Smithsonian Institution in Washington, D.C., the Computer History Museum in Mountain View, California, and other locations. ENIAC remains a milestone in computer development. The brilliant work of Eckert, Mauchly, and the many men and women who contributed to this amazing industry is a legacy that lives on to this day.
So this is all about ENIAC. Now come to vacuum tube. So in previous slide, you have seen that one fellow is changing one panel. Okay, this panel vacuum tube. So vacuum tubes need to be changed each and every time. Okay, so I'm not showing you vacuum tubes video here. I'm showing you in binary number system so that you may be able to understand why we use vacuum tube and why this vacuum tube changes the computational world. Okay, binary is in terms of 0 and 1, yes or no, no or yes, false or true. Okay, so this is how, because this nature of unidirectional travel or traverse of electron, we use vacuum tube to develop binary logic. Why other logic fails and why binary logic is still in use despite of its complexity. Okay, so we will discuss in next slide when data representation is starting. Come to 1930s, between 1930s and 40s, Alan Turing developed a universal Turing machine. Okay, and this is also known as universal machine. Here, like in previous machine, what happened? We need to change the wiring. Here we need not to change the wire. He envisioned a computer that could perform any task by simply changing a program. Okay, simply changing the program rather than by changing the electronic component. When we are changing electronic component, then it is known as hardwired control. Okay, hardwired control. And when we just change the program, then it is known as microprogrammed control. Microprogram control. Because you all are computer science student, therefore I had written this terminology here, but this terminology you cannot find in your computer fundamentals book. Okay, but you need to remember this term whenever you are in semester 4 or semester 3rd with subject CSAO, that is Computer System Architecture and Organization. Then these terms. Okay, so what Alan Turing did, he has developed a computer where only we need to change the program. Means just we need to write the code. That time program is written like 320, 390, 400. This is the writing style. Okay, and these codes are known as mnemonic codes. Okay, so suppose 320 performs transfer of data, 390 performs addition of data, and 400 performs moving of data. So these all thing is done with the help of mnemonic code, and due to this flexibility we can write program in any manner. Okay, any style, so that it will produce the result. That's why, and that is the biggest achievement of that time, that we need not hardwired or chip for each and every function. Like you want to integrate particular equation, then for that purpose we need to design different microchip. For other integration we need to develop other microchip. So better to write or better to develop a device in which we just write the equivalent differential equation or integration equation and it will give the result. Okay, so this was done by Alan Turing. That's why one person asked about Alan Turing that he is father of computer. So no, he is not father of computer. He is father of modern computing. Okay. Now come to next machine. This is John von Neumann model. Okay, and this he has developed a concept stored program organization. What is stored program organization? In stored program organization, it was developed to store the program, okay, and program would be stored in CPU or central processing unit. So there are different components. Any device which are not able to produce output has no meaning. Okay, each and every device, each and everything produces some dedicated output. So output is a must. Maybe zero or more number of input is there, and input is processed through some processing element. So input is processed through some processing element and it will produce the output. Okay, these processing element may be anything like flip-flop and other thing, but this is general concept. Now come to a special or one E. Neumann concept of computer. One E. Neumann developed a model where memory unit is also there. What is the use of memory unit? See, before this system, we need to write a program or we need to feed a program, and then only this program will produce the output. Now the concept is that we can feed the program and we can store the program, we can store the data also, and we can store the output also. So each and everything can be stored in memory unit. That's why this system is coming into existence. So input like punch card and output like punch card or printing. Okay, nowadays in today's context, input may be keyboard, mouse, or any other devices which is able to capture your input data, and output may be anything which is able to produce the output. Now come to central processing unit. Unit is equipped with arithmetic and logical unit. Each and everything, whatever you want to do, is done with the help of arithmetic and logical unit only. Okay, no other unit is there. If suppose you say that GPU is working, GPU is working for that, so GPU is another kind of processing unit which is capable of calculating several things. Okay, and it is related with rendering calculation, rendering or graphics related calculation. So what does GPU do? Nowadays GPU can be measured in terms of flops. Okay, what is flops? Flops are floating point operation per second, and floating point is a special kind of operation which includes decimal point. That's why it has a special meaning, and it has we need to solve it by using a special kind of arithmetic. So that's why GPU is there, and nowadays GPU is measured in terms of gigaflop. So whatever more the number of gigaflops, the faster the GPU is. Okay, and tends to supercomputing also. Supercomputing, super personal computing, you can say. Okay, this term is not there, but super personal computing is what? Today our computer is running in 1x speed, and with the help of GPU you can increase your speed by 300 times. So this is the beauty of GPU. Let us come back to our original concept, that each and everything is devised using plus, minus, asterisk and slash, or addition, subtraction, multiplication and division. Okay, plus the logical means and, or, etc. So with the help of these things we can calculate anything, we can recognize a person, we can find the, we can forecast the weather, we can also forecast the market, each and everything. So arithmetic and logical unit is there. Okay, and to control this unit we have control unit. Like in our case, heart is there. If heart is running slowly or fastly, based on this we are able to do certain work. Okay, If heart is slow, I don't know what is the medical implication of that. And if heart is very fast, suppose we are running very fast, then automatically we get tired. Okay, due to this heartbeat is very fast. So this heart is there. Control unit is heart of CPU, and it synchronizes the operation. Suppose I am going to add 99 with 99. So what will be the answer? Its answer is 198. But if synchronization is not there, then answer will be 1818 or any other number. Okay, why? Because 9 plus 9 is 18 and 9 plus 9 is 18. Because of lack of synchronization, this answer is coming wrong. So this control unit synchronizes all these operations. I'm not going to discuss in detail because there is another thing, but you can understand that why control unit is placed here, although arithmetic and logical units is already present there. Fine. So this is the concept. To synchronize each and everything, we need control unit. Clear? So this is whole architecture of John von Neumann. Okay, so you need to write several sentences according to this, and you need to, whatever I had explained, you need to write in terms of your word. And don't go on GPU, because GPU is not part of John von Neumann architecture. Only CPU is there, and memory unit, input and output unit is there. And CPU consists of two units: control unit and arithmetic and logical unit. So I had already explained. You can also explain that you can calculate anything, you can recognize anything, you can predict anything using arithmetic and logical unit. Fine. Now come to transistor. In 1947, one revolutionary change comes into existence. So in the laboratories of Bell Telephone, John Bardeen, Walter Brattain, and William Shockley discovered the transfer register. Okay, earlier it was known as transfer register, later labeled the transistor to shorten this transistor. So transistor is coming into existence. What are the advantages of using transistor? Increase reliability. Why increase reliability? Because it uses the semiconductor logic. It uses silicon or germanium, whatever type of semiconductors are there. It consumes less power, 1/20th of the electricity of vacuum tube. Okay, in case of vacuum tube, power dissipation is very high, and you need to install one power station, small power station. Here it is very low. 120 is very low, less amount, and where a fraction of cost. Okay, with a very small amount of money for that, because each and every time we need to refresh the vacuum tube, so it costs more. Okay, whenever one vacuum tube fuses, automatically we need another, and because of heat dissipation and power dissipation, it is not working with full efficiency. Although that was milestone, that was produced the nuclear physics calculation in 6 hours only instead of 365 not 100 years calculation. Okay, this tiny device had a huge impact and extensive implication for modern computers. In 1956, the transistor won its creator the Nobel Peace Prize. Okay, so Shockley won the Nobel Peace Prize for that invention, because that is a revolutionary device. So let us see the video. It also includes diode wall vacuum tube in little bit, but it is very helpful for you.
Modern computers are revolutionizing our lives, performing tasks unimaginable only decades ago. This was made possible by a long series of innovations. But there's one foundational invention that almost everything else relies upon: the transistor. So what is that? And how does such a device enable all the amazing things computers can do? Well, at their core, all computers are just what the name implies: machines that perform mathematical operations. The earliest computers were manual counting devices, like the abacus, while later ones used mechanical parts. What made them computers was having a way to represent numbers and a system for manipulating them. Electronic computers work the same way, but instead of physical arrangements, the numbers are represented by electric voltages. Most such computers use a type of math called Boolean logic that has only two possible values, the logical conditions true and false, denoted by binary digits 1 and 0. They are represented by high and low voltages. Equations are implemented via logic gate circuits that produce an output of 1 or 0 based on whether the inputs satisfy a certain logical statement. These circuits perform 3 fundamental logical operations: conjunction, disjunction, and negation. The way conjunction works is an AND gate provides a high voltage output only if it receives 2 high voltage inputs, and the other gates work by similar principles. Circuits can be combined to perform complex operations like addition and subtraction, and consist of instructions for electronically performing these operations. This kind of system needs a reliable and accurate method for controlling electric current. Early electronic computers like the ENIAC used a device called the vacuum tube. Its early form, the diode, consisted of 2 electrodes in an evacuated glass container. Applying a voltage to the cathode makes it heat up and release electrons. If the anode is at a slightly higher positive potential, the electrons are attracted to it, completing the circuit. This unidirectional current flow could be controlled by varying the voltage to the cathode, which makes it release more or less electrons. The next stage was the triode, which uses a 3rd electrode called the grid. This is a wire screen between the cathode and anode through which electrons could pass. Varying its voltage makes it either repel or attract the electrons emitted by the cathode, thus enabling fast current switching. The ability to amplify signals also made the triode crucial for radio and long-distance communication. But despite these advancements, vacuum tubes were unreliable and bulky. With 18,000 triodes, ENIAC was nearly the size of a tennis court and weighed 30 tons. Tubes failed every other day, and in 1 hour, it consumed the amount of electricity used by 15 homes in a day. The solution was the transistor. Instead of electrodes, it uses a semiconductor like silicon, treated with different elements to create an electron-emitting N-type and an electron-absorbing P-type. These are arranged in 3 alternating layers, with a terminal at each: the emitter, the base, and the collector. In this typical NPN transistor, due to certain phenomena at the PN interface, a special region called a PN junction forms between the emitter and base. It only conducts electricity when a voltage exceeding a certain threshold is applied. Otherwise, it remains switched off. In this way, small variations in the input voltage can be used to quickly switch between high and low output currents. The advantage of the transistor lies in its efficiency and compactness. Because they don't require heating, they're more durable and use less power. ENIAC's functionality can now be surpassed by a single fingernail-sized microchip containing billions of transistors. At trillions of calculations per second, today's computers may seem like they're performing miracles. But underneath it all, each individual operation is still as simple as the flick of a switch.
This is how transistor works, and you have already seen that how this is beautifully shown that how we need to change vacuum tubes in each and every hour, and this was also known as diode valves. Okay, and vacuum tube is very common terminology, and these are traditional transistor and latest transistor. So and this was known as transistor radio because it uses transistor technology or transistors as a circuit. That's why a lot of transistors are there. That's why this radio device was known as even today also the persons are using this particular device as transistor. Okay, and this is nothing but your radio. Now come to first computer bug. So while writing a program, initially what happened, whenever you are writing a program, it was based on column, like column numbers are there. So here you need to write the code, particular code or particular label, and from a particular column, we need to write the program. So one bug was there, and due to that bug, we need to write the program here from here. So whenever writing a program from this particular column, it will give an error. That's why this particular terminology is coming into existence, bug. What happened? We have this bug is put here, it is put additionally, but due to that bug, the fellow has written program from not visible, means this paper is like this and we need to write program like this, and due to this bug we have written the program from this place. Okay, due to this problem, error was there. Okay, and this error was known as bug because this bug was there, and due to that bug this create a bug. Okay, so this is the interesting thing, and she is Grace Hopper, and she has coined the term bug. Fine, because it was restricted for particular column. Okay, we need to write from a particular column. That's why this bug was coming into existence. Now come to Altair 1975. This device was introduced by Bill Gates. Okay, and this was a standalone device. No monitor, no keyboard, or no video display. We need to purchase separately. So the invention of transistor made computers smaller, cheaper, and more reliable. Therefore, the stage was set for the entrance of the computer into domestic realm. In 1975, the computer comments. Okay, so with this device, a personal computer, because it is very small device, like what we can say, whatever boxes you are like shoe boxes, its size is around shoe box. Okay, under the leadership of Ad Roberts, the micro instrument and telemetry company MITS wants to design a computer kit for the home hobby set based on the Intel 8080 processor. Okay, it was a 8-bit microprocessor capable of controlling 64 kilobyte of memory. The MITS Altair, as the invention was and a letter called, was debuted on cover of January edition of Popular Electronic Magazine. Electronic Magazine was there, presenting the Altair as unassembled kit, capped cost to minimum. Therefore, the company was able to offer this model for only $395. Okay, supply could not keep up with the demand because it was very new kind of system and new kind of personal computer, and they have never thought about how this or the demand is very high for this particular device. Okay, but the other facts are no keyboard is there, no video display is there, and no storage devices are there. So we need to purchase video display additionally, storage device additionally, and keyboards are also additionally. So with this, it will run very clearly. In 1970s, transistors were replaced by integrated circuit or chips, given computers tremendous speed. Okay, what is the beauty of integrated chips? We can integrate thousands of transistors in a single IC. Okay, at a rate of millions of calculation per second, MIPS, million instruction per second. Okay, in 1970, John Hub invented the microprocessor and entire CPU on single chip. This allowed for building of microcomputer or personal computer. IBM PC was created in 1981. On August 12, 1981, IBM announced its own personal computer using 16-bit Intel 8088 processor. Okay, earlier was 8080 and it is 8088, allowed for increased speed and huge amount of memory. Unlike the Altair that was sold as unassembled computer kits, IBM sold its ready-made, means the display is there, keyboard is there, and storage is also there, machine through retailers and by qualified salesperson, because we need to explain each and everything, what is the how to use and what are the programs we need to install for this particular system. Because before 1984 or other means before that time, operating system concept of operating system was very small. To satisfy consumers appetite, and increased usability, IBM gave prototype IBM PC to a number of major software companies. Okay, for the first time, small companies and individuals who never would have imagined owning a personal computer were now open to computer world. So this was a history of IBM PC, IBM personal computer. Uh, Now come to Macintosh. Okay, so Macintosh is developed by, who was the inventor of this Macintosh?
Steve Jobs.
Steve Jobs and Steve Wozniak. Okay,
Steve
so
Jobs.
IBM's major competitor was a company led by Steve Wozniak and Steve Jobs, the Apple computer. The Lisa was the result of their competitive thrust. So before Apple, Lisa was there. Okay, this system differed from its predecessor in its use of mouse, then a quite foreign computer instrument in lieu of manually typing commands. However, the outrageous price of the Lisa kept it out of reach for many computer buyers because of Apple. Apple has, Apple is, I don't know what is the reason. The same thing is there, the same operating system, same type of commands are there, but their prices are almost double. Okay,
So because
Apple's
of
brainchild
hardware.
was Macintosh. Yes, hardware is also same. Okay, hardware is also same. They are using i7 microprocessor. The same motherboards are there. So little bit
Uh,
difference is there, but not like that. The cost of this particular system is very, very, very high. Very, very high
sir,
is okay, but yes,
it is a marketing policy.
Because
They
they are
somehow
not
wanna
manufacturing in India.
so many things
no.
are there. So many
They
things
wanna
are there.
The
they wanna
premium feel
sell their
कराने के लिए.
product as a premium product. So that's why they
Premium.
That's
have to
where the
give.
brand comes.
Though they do not have any good reasons on the basis of specs. If you know the specs, you won't buy a Mac at all.
Class, specific class. Okay, class property makes it means premium computer is there, and it is designed for a particular class of persons, those who can afford the Macintosh system. So but later, because it was flop, Lisa was flop, Apple's brainchild was Macintosh. The Macintosh 2 would make use of graphical user interface. GUI was coming into existence. Introduced in January 1984, it was an immediate success. The GUI made the system easy to use. Apple Macintosh debuted in 1984. It features a simple graphical interface, uses 8 megahertz 32-bit Motorola 68000 CPU. Okay, this is Intel-like processor and has built-in 9-inch black and white screen. Okay, cost is around $2500. Okay, so let us see.
Hi everyone, Knivsey here, and in this video, we're going to be going back to the past. Back to 1984 when Apple's most iconic computer was released, as well as when Stranger Things in Season 2 takes place.
Yeah, totally tubular.
So in this video, we're going to be taking the original Apple Macintosh from 1984 and making it the main centerpiece of our workspace, in a technology revisitation made possible by TELUS, the mobile carrier making the future friendly. Let's get started. This all starts with the computer, the Apple Macintosh from 1984, in this case the 512K, which gets its name from the amount of built-in RAM, which you can probably guess is 512 kilobytes. This computer in the 80s was pretty expensive for a lot of people at a price of $2,795 US, which is equivalent to $6,443 today.
This was sort of the standard price for a PC back in the 80s, if not a bit cheaper, but the 512K actually had a trick up its sleeve compared to other PCs. It had a graphical user interface. Now, Apple didn't actually totally invent the whole graphical user interface for desktop computers, but made it incredibly popular and more approachable. The first main computer with a graphical user interface was the Xerox Star. However, it actually cost a lot, it was totally niche, and really nobody bought it.
The display screen shows your working environment. We call this the desktop. It is an electronic analog for an office. On the screens are small pictures or icons representing familiar office objects.
Apple didn't actually just steal the interface from the Star, but it worked with Xerox directly to build its own software version, which we now know as macOS. The Macintosh's external design is undeniably iconic. It's an all-in-one computer that is very compact, it's portable with an actual handle up top, it's minimal, and carefully designed in many aspects. At the front, there's a real absence of pretty much anything except for the floppy disk drive, the Apple logo, and the display, of course, which is a 9-inch black and white CRT with a resolution of 512 by 342 pixels. And the back, like today's Apple computers, is where you'll find pretty much everything else. There's the 5 total ports and the PRAM battery cover. Now, moving away from the computer itself, for peripherals, I'm using the stock Macintosh keyboard and mouse. The keyboard provides a very satisfying typing experience. And it's also hella thick too, especially compared to Apple's new Magic Keyboard. And for the trackball mouse, it has just one button up top, adding to the very minimal nature of this entire system. This all came at a time when using a mouse was sort of a foreign concept for a lot of consumers. Now, also with the system, I have my floppy disks, of course, and floppy disks with the Macintosh are used for both program access and file storage. This computer also came out at a time when email, cloud storage, and easy file transfers weren't totally easy, so we're dealing with printing and faxing a lot of stuff. So part of my setup, I also have the Apple Image Writer 2 printer. This printer came out actually a year after the 512K was released and used a process called dot matrix printing. Today we're familiar with laser or inkjet printers, and they're much more advanced and quieter and faster and just generally more reliable, but I actually prefer the design of this printer. It feels much more charming and personal. It just looks a whole lot better than today's printers. I also have a few other key desk essentials here too, like this highly adjustable, very flexible task lamp for working into the late hours of the night, and next to my computer, I keep this very minimal Braun clock. And even though it's missing a piece up top, I like the clean design and the Braun clock face. And essentially, that's my setup. I find it really amazing how our phones today are able to do so many advanced things that people many years ago were only able to do on expensive pieces of tech and multiple pieces of tech. We can call, we can text, we can play games, type out essays, and I did it during class once, and trust me, it's not really as bad as it sounds, edit videos, and do pretty much everything we can just think of to do on our phones. Our devices today are more advanced and more powerful than we could ever imagine. In all honesty, looking at old technology and comparing it to new technology is one of my favorite things to do as a technology YouTuber and just as a person in general. The rate of advancement in technology is incredibly fascinating to me personally. So a huge thank you to Mobile Carrier TELUS for helping me find these products to make this.
So this was a Macintosh computer, and now come to Windows. Okay, so Windows is also the frontier of graphical user-based system. So let us see, and this is last slide of modern computer development or computer fundamental. I think there is no voice for this particular video. So this is our monitor, and here you can see the keyboard, and this is our CPU. Okay, like in Apple's case, the CPU and monitor is coming together, but here two different pieces are there. This is our CPU and this is our monitor. Now we restart the system, and it is starting the Microsoft Windows operating system. And this is the monitor is quite big. Okay, and now it is checking for the floppy disk, parallel port, serial port. It was booting the system actually. And yes, now this is Microsoft 3.1 Windows is coming into this system, and this is also based on graphical user interface. Okay, and this graphical user interface and the program very similar to the Apple Macintosh. It was coming in 1985 and developed by Microsoft, and the concept was given by Bill Gates. Okay, and the name of an extension of file is exe. So file extensions concept is coming from Windows, and this is exe shows you need to double click on this particular program. It will automatically run the program. Okay, monitors are there. So many things are very similar to Apple's Mac operating system. So this was earlier stage of operating system. Okay, earlier stage of graphical user based operating system. The keyboard is quite similar. So this is in different language, I think, but you can enjoy the graphical user interface also. So this is how Windows will be there for you. So with this, we close the computer fundamental slide or topic, and now it is request from all of you. If you have any question, then you can ask. Okay, so turn on your camera so that I may be able to show your attendance, visual attendance, and I'm on Excel
Excuse
sheet
me, sir.
attendance here.
Excuse me, sir.
Sir, my webcam is
Yes.
not working here.
Okay, but others webcam is working there, na?
So what was G-flop?
G
What was
flop
the
is
full form?
giga floating point operation per second. Floating point is a special kind of operation. Okay, so giga floating point operation per second. Giga means 2 to the power 30 floating point
Sir,
operation.
do we have to make notes for this particular slide that you have showed us?
You can write notes in brief so that you may be able to understand what you need to write, because each and everything is there in a historical form, and I had given you a small kind of things, okay, so that you may be able to write anything about this.
Okay, sir.
Yes, any other question?
Sir,
Yes,
sir, can you please suggest the book for
my suggestion of book is Venugopal. Okay, this is for C programming, and for computer fundamental you can use any tutorial site.
So we do not have to learn everything in historical word by word, right? We just have to get a grasp, or do we have to learn everything?
Do we learn to means do we have to learn?
I mean, do we have to memorize all of the computer and names of scientists, those who worked on it, everything?
If you are able, then it is okay. If you are not able, then at least approximate duration you can write. Like Pascal's computer is there. Okay, Pascaline is there. Before Pascaline, Abacus was there. Abacus was in 4th century before Christ. Okay, so you can write that. Clear or not?
Yes, sir.
So there is no problem, and means approximate duration. I am going to means I am forwarding you one